Right. Welcome. Good evening, all my dear students, all my WOC students. Welcome back. We are back again with the term 2 revision students. Yes, your term 1 examinations went wonderfully. I'm so happy for you all. Smiles around. I was so happy to see your hard work and your cooperation with your WOC channel. Yes. Remember, students, world of chemistry is always there for you all. Every time, world of chemistry is just like a shadow behind you, right? We are going to start off with your term 2 revision from today. I'm going to take in detail explanation of each and every topic. I've already done complete term 2 syllabus in one shot videos. A playlist is kept in the community tab for both grade 11th and grade 12th students, where I have completely done term 2 chapters like electrochemistry, I have done chemical kinetics, I have done aldehydes, ketones, amines, surface chemistry, polymers, everything is done, students. Yes, so the term 2 list is kept in the community tab. Please watch it. Now, what is this? This is again a detailed topic wise discussion along with the MCQs. I'll be discussing case based questions. I'll be discussing assertion reasoning questions, right? I'll be discussing one shot, 1 mark answers. I'll be discussing 2 marks. Like that, it is a detailed explanation. So, today the topic which I've picked up is nothing but electrochemistry. Yes, the most important chapter for your term 2. Yes, very important chapter. First, we will see the concept. Yes, and then we are going to solve the related MCQs. Right, students? Gradually, this journey goes on. Important thing, you are request is please share it with your friends. Share it to maximum students. Yes, if you are showing interest from your end, Vanimam will become more and more energetic to send you all more videos. Yes, so keep sharing the video. I'll come back with more and more videos with the same topic in a detailed way. Let's start the chapter. So whenever we talk about electrochemistry, these are the topics which are prescribed for your 2022 boards. You need to learn about the concept of redox reactions, what is meant by EMF of the cell, and the related numericals which are there. That also we will be doing. You're going to learn about standard electrode potential, that is nothing but SEP. This is what we say. We'll be learning about, and numericals also will be solving here. Nernst equation and numericals. Yes. Relationship between Gibbs energy change and EMF of the cell. Right. So all these are numerical based chat topics, students. Everything includes numericals. You need to learn the numericals this time carefully. Then comes, we are going to study about conductance in electrolytic solutions, in that specific molar conductivity. So variation of conductivity with concentration, Kohlraasch law, and electrolysis. So everything we are going to study. The topics which are deleted, don't concentrate. What are given to you, please learn it carefully. Okay, students. So this is the index. Let's start with the topic. Today we are going to discuss certain part of the topic and do the related MCQs also. So take a notebook, start writing. Term 2 revision, world of chemistry. Vani ma'am is always with you. Topic number 1, it goes like this. Yes. So the first topic. When we talk about redox reactions, remember students, redox reactions basically, or when I talk, we have studied in grade 11th. Redox stands for your reduction process. Yes. Ox stands for your oxidation process. Correct? Na? So in this redox reaction and oxidation reaction, first we should know what are the different definitions we have. So first let us take the topic oxidation. Check. Oxidation can be combination of oxygen, just like this. Oxidation process can be removal of hydrogen, just like this. See here, HCl has got converted, or if I have to tell you, in this HCl and MnO2, you're removing the hydrogen from there and convert. Yes, students, right? So careful, removal of hydrogen is one concept. Second concept, or the third concept, addition of electronegative atom. You are adding an electronegative atom to a particular compound. Yes. Next, removal of electropositive element. So addition of electronegative atom and removal of electropositive. So what are we doing? We are removing an electropositive element out. That is also oxidation. Next, point number 5. Oxidation is also loss of electrons. See, sodium is losing one electron and becoming a cation. Iron is losing one electron, becoming a cation. Like that. One more definition, increase of oxidation number. right? And these are the examples of these. That means whenever you're learning oxidation process, 1, 2, 3, 4, 5, 6 definitions you should always have in your mind. Let's see what is meant by reduction process. Yes, reduction can be removal of oxygen. Yes, I have taken PbO and I have removed oxygen from this. Reduction. Addition of hydrogen. Yes, you're adding hydrogen to this. This is also reduction. You're removing an electronegative atom. Take out the electronegative atom out. It is reduction. You're adding electropositive atom. Just check. Electropositive atom. Now chlorine were 2. Now mercury you have added 2. So electropositive atom you have added to this compound. Isn't it? So addition of electropositive atom. Easy. That is also reduction. If something is gaining electrons, then also it is reduction. Last but not the least, decrease in oxidation number. So oxidation was increase in oxidation number. This is decrease in oxidation number. How many definitions? 1, 2, 3, 4, 5, 6. You need to remember all. Now both together, reduction and oxidation together becomes redox reaction. So always remember, if I take an example, so this is an example of a redox reaction where, check here, chlorine, how many atoms it has, or what is the valency? 1 minus 1. So 3 chlorines is minus 3. If it is minus 3, this is plus 3, correct? Same here, 2 chlorines are including minus 2, so this will become plus 2. Right. Now in this reaction, 2 chlorines minus 2, so iron plus 2. The total charge should be 0, isn't it? Now in the same way, SnCl4. In this, it is minus 4 and this is plus 4. Correct? Now check students. This is a redox reaction. Why? In the case 1, let us see, Fe plus 3, it is getting converted to Fe plus 2. What is happening here? Here, there is a decrease in oxidation number. Am I right? Yes. Now, second thing, SnCl2 from plus 2, it is going to plus 4. What is this, students? It is nothing but increase in oxidation number. Now, you only said just now, let us go back. You said if the oxidation number, let's check the earlier one. See here, if it is decrease in oxidation number, it is reduction, you said. Let us come back to this. Decrease in oxidation number is reduction. This process, that's nothing but gain of electrons. Here what is happening? It is gaining electrons. Gain. Here increase in oxidation number is oxidation. What is happening here? It is losing electrons. Loss of electrons. Correct now students? That's all. So this is your redox reaction. Next important thing, gradually when we come to electrochemical cells are, what are they? They are basically, what are they going to do? They are going to convert electrical energy into chemical energy. Means a particular electrical, with the external supply of current, you are going to generate a chemical reaction through which the whole circuit gets completed. Got it? So electrochemical cells, as the name suggests, electrical energy is converted to chemical energy. So EE is converted to CE. That's all. This is what is your electrochemical cell. There are two types of electrochemical cells. One is galvanic cell, where we are going to study about voltaic cells. One more is electrolytic cell, where we'll be picking up sodium chloride example and learning it. Right, students? So let us first see what is this galvanic cell or voltaic cell. Now, simple. In a galvanic cell, the construction looks like this. What do you have? You have two cells, electrochemical cells rather. In that, you have electrolytes. One is zinc sulfate electrolyte, one is copper sulfate electrolyte. In that particular solution, you are dipping the zinc rod, which is acting as an anodic compartment. You are dipping a copper rod, which is acting as a cathodic compartment. Always I said, at anode, oxidation process occurs. At cathode, reduction process occurs. Correct, students? All right. So this is your Danial cell or the voltaic cell. Remember, the voltage, the Danial cell, the voltaic cell, the voltage is 1.1 volts. So that is the electrode potential value for this. 1.1 volts is a electrode potential value for the cell. Now what happens? Always remember, electrons, they flow from anodic compartment to cathodic compartment. This is what is the rule. Okay, right. And opposite, current flows from cathodic compartment to your anodic compartment. Remember that, cathode to anode. This is what is the concept. Yes. Now important. Just take here, students. What happens? Suppose if the external circuit, whatever. Now one more thing, it is connected to the voltmeter. It is also connected to a salt bridge. Remember, if the external voltage, whatever you're supplying, if it is less than 1.1 volts, okay, if the E external is less than 1.1, because the cell potential for Danial cell, how much is it? It is 1.1 volts. Suppose whatever you're supplying, the external voltage you're supplying, external electrode is less than 1.1 volt, then what happens? The electrons will flow from anode to cathode. Got it, students? They'll flow from anode to cathode in this direction. Suppose if the external circuit value, the electrode potential value is more than 1.1 volt, what will happen? Then the electrons will flow from anode to cathode in this direction, because if that is more, it will start flowing in the opposite direction. Yes, students? Yes. Suppose if the external circuit is equal to 1.1, the whole reaction comes to a stop. See here, the voltmeter, it's showing 1.1 volt, 0, 0. It has come to a stop. Means both the forward reaction and the backward reaction, it is complete. The whole circuit is complete. Once again, if E external is less than 1.1 volt, what will happen, students? The electrons will flow from anode to cathode. This is what is the first concept. Second concept, if E external value is greater than 1.1 volt, the external circuit value, then what will happen? The electrons will flow from cathode to anode. Correct? This is what you should remember. Suppose if the electrons, everything, the reaction is complete, the circuit is complete. So the reaction comes to a stop. Easy? That is what is your galvanic cell. Yes. Now important. They're going to ask you what is a complete galvanic cell reaction. Now understand carefully. I said at the anode compartment always oxidation process occurs. Anodic cell or anodic compartment. At cathodic compartment always reduction process occurs. Yes, students. Once see the diagram here. Yes. So here this one, in this particular thing, always anodic oxidation reaction occurs. Here cathode reduction process occurs. So the same thing I have written. This is the anodic half cell reaction, cathodic half cell reaction. So this electron gets cancelled. I am writing the overall redox reaction. Zinc solid, copper in aqueous, because in ions you'll get in aqueous. Then comes copper solid and zinc plus 2. That's all. This is the overall galvanic cell reaction. What is the electrical potential of this? It is nothing but E cell, or the electrical potential of this is 1.1 volts. Remember, we have marked it here also. E external, the E cell of this particular electrode potential is 1.1 volts for Danial cell. Done, students? Easy. Now important thing, they will ask you what is the role of the salt bridge. Yes, this is your salt bridge. See the important thing. So basically important thing is salt bridge maintains electrical neutrality. It will not react. It will not allow any other ions to move towards that. Means it will make the whole cell electrically neutral. It will not mix up both the ions. Easy. Next important thing, yes, it is made up of a glass tube, which has potassium chloride or ammonium nitrate. So in the form of a gelatin, inside this, it's in the form of a gelatin which is made, and it is inserted inside in the form of a gel, so that it is not allowing any of the ions to move to it. So here they've given gelatin. What is the role? It allows ionic movement but prevents any kind of mixing. It will prevent mixing. Remember that. This is the role. They will ask you for your 3 marks question or maybe 2 marks question. Simple answer. Yes. Okay. Then what is the role of the potassium chloride or ammonium nitrate? See here, you're taking potassium chloride here, potassium chloride or ammonium nitrate. What is that thing? What is the use of that? It will help in or the ionic mobility. Why did we take that? See, in case of K plus and Cl minus, both the mobilities are same. The mobility of the cation and the anion the same. That's why we can easily insert them into the particular salt bridge, so that when the particular electrons are moving, the mobility, this will not interrupt, because both the mobilities are same. No, they will not participate in the reaction. Got it, students? So only it will allow the passage or the movement of anions and movement of cations. Yes, that is what is a salt bridge. So remember these points and they will ask you for your 2 marks question. Now let us see the MCQs which are related to this. Yes, let's check. So please concentrate and my request is take a notebook and note it. So take a notebook students, take a notebook and note it. So what should be the heading? WOC term 2 MCQs. Write down WOC term 2 MCQs. Write like this and check all will be covered. Alright, let's start. First thing, electrochemistry deals with, yes, obviously, production of electrical energy from chemical energy, correct? No? Because of the chemical reactions, electrical energy is released. That is nothing but your 1.1 volts in Danial cell. Next question. Electrochemistry is used. Yes, what? Everything. See here. I can use it for, actually answer is all of these. I can use it for all of these things, students. So this is a general question. So remember, electrochemistry is used for extraction of non-metals like chlorine and fluorine. Next, application of electrochemistry includes what? Yeah, again, the general question. Yes, it is all of these. It is used in fuel cells, for generating fuel, electro-refining also, refining process of the different metals, electroplating, coating, galvanization sort of thing, everywhere. Yeah. Next, the study of electrochemistry is totally dependent upon the concept of what? Yes, redox reaction. Both reduction process and your oxidation process happens here. Done. Next question. A redox reaction is the one in which, yes, what happens? Yes, it is nothing where oxidation and reduction happens simultaneously. Easy. Okay. Next question. In the following reactions, sodium gives Na++ electron. Okay. Oxygen takes 2 electrons because it requires 2 electrons. So 2 electrons and becomes oxygen atom. Now they are asking you particular thing. What actually is happening? Okay. In the first reaction, I know oxidation reaction is happening. Okay. Second reaction, okay. Second reaction, what is happening? It is taking up 2 electrons. Oh, taking up 2 electrons. That should be reduction. But here, what is happening? It is taking 2 electrons. It is forming oxygen atom. Now, which one is right? Let's see. One is reduction reaction, they said. This is wrong. One is oxidation reaction. Two is reduction, they said. Students, careful. See here. This is also wrong. I'll tell you why. Both 1 and 2 are reduction reactions. Wrong. Both 1 and 2 are oxidation reactions. Oh, this is right. Why? Because, observe carefully, students. In this case, sodium is losing 1 electron. Okay. Oxidation, loss of electron. Oxygen minus 2 again. It has taken up, see here. It is also losing, see here. Minus charge. Yeah. It is also losing electrons. Isn't it, students? That is what is the concept. Both are oxidation reactions. Yeah. Next question. In the reaction, SnCl2 plus FeCl3 gives SnCl4 to F gives F plus FeCl2. What is right? Careful, students. When such questions are given to you, please check. Check the oxidation numbers. Here, how much is it? This is minus 2. This is plus 2. Here, minus 3 plus 3. Here, minus 4 plus 4. Here, minus 2 plus 2. So, let us see. The oxidation number of Fe decreases from plus 3 to plus 2. Yeah, it is right. Oxidation number of Sn increases from plus 2 to plus 4. Easy answer. Right. Next question. The dash of electrons in the reduction cross causes what? The dash of electrons in the reduction causes oxidation number of element. Okay. Reduction process means gain. When something is gaining, oxidation number automatically decreases. Right, students, easy. A device in which electrical energy is produced from chemical reactions. Okay, just see. Electrical energy from production, it is nothing but electrochemical cell. It is an example of galvanic cell. It is an example of voltaic cell. So the correct answer is double cross, double tick, all of these. In electrochemical cell, your electrical energy and chemical energy, both the things which we are observing, isn't it, students? All right. Next, the chemical reaction taking place at the anode is easy. Oxidation, nothing but loss of electrons. Okay. Next question. Anode is an electrode at which, okay, what happens, students? Anode is an electrode with which electrons flow out of the electrolyte. Correct? Na? When we have two cells like this, a very bad diagram. This is your salt bridge. Yes, this is your anodic compartment. This is your cathodic compartment. What will happen? Always electrons will flow in this direction to this. Now, students, yes, this is your anodic compartment. This is your cathodic compartment. So what will happen always to the electrons? The electrons are going to flow from the anodic compartment to the cathodic compartment. Yes, that is what we have said. Easy? Sure. That is what we said. Easy concept. Understand the concept. Chemistry is easy. Okay. Right. Next question. Which of the following reaction is possible at anode? Which is possible at anode? Now check, students. Let us check one. In the first one, here it is going from Cr plus 3. Now here charge is there. Okay. Water molecule, this is how much, students? Plus 1, because 1 hydrogen. Chromium here in this case is plus 6. Okay. 14 hydrogens in this case is plus 1. All right. Now what happened in case 1? In case 1, let us take from plus 3, it is going to plus 6. Correct? What is this? This is oxidation process. Right? Now here plus 1 to plus 1, no problem. Okay. Let us see the next one. In Fe, this is 0. It is going to minus 1. Yes. So in case 2, it is 0 to minus 1. It is nothing but reduction. Correct. In the next one, this is 0 to 0. This is going to minus 2. This is hydrogen. This is plus 1. This is hydrogen. This is plus 1. So we'll see in the C case what happened. From 0, it is going to minus 2. Plus 1 same, nothing to take. So this is reduction. So which is the reaction, students? Which is possible at anode? What happens? Oxidation process should happen. So which one is happening? Oxidation. First one. So case 1 is oxidation process. Okay. Remaining all are plus ones. No, plus 1 to plus 1, plus 1 to plus 1. Nothing to consider. Right. Next case. Which of the following is an example of an anodic reaction? Okay. Anodic reaction. Again same. Anodic reaction, oxidation should happen. Loss of electrons should happen. Okay, let us see. In this case, gain is happening. This is not the answer. In this case, gain is happening. This is not the answer. In this case, there is no change. Plus and plus, ionic reaction. Now, just check. In this case, zinc from 0, it is becoming plus 2. Okay. In C case, from 0, it is going to plus 2. It is nothing but loss of electrons. Nothing but oxidation process. See? Okay. That's why they have asked anodic reaction. Next, chemical reaction taking place at cathode is cathode reduction. That's nothing but gain of electrons. Okay, done. Next one. The electrolytic decomposition of dilute sulfuric acid with platinum electrode in cathodic reaction. Okay. It's basically dilute sulfonic acid with platinum electrode in the cathodic reaction they asked. So it is reduction. Easy. Even if you don't know the reaction, see the electrode, mark it. Okay. The half cell reaction is the one that, okay, half cell reaction is the one that takes place at one electrode. Half cell, correct na? See here. Oxidation half cell, it always happens at anodic compartment. Am I right, students? Anodic compartment. So anodic compartment, half cell, oxidation. If I say reduction half cell, it always happens at cathodic compartment. Am I right? Cathodic compartment. That's all. Easy? So that's why it is half. Next question. Which of the following is incorrect in a galvanic cell? Okay, incorrect in a galvanic cell. Galvanic cell is what, students? Basically, it will have a redox reaction happens, correct? Oxidation occurs in anode, it is right. Reduction occurs at cathode, this is also right. The electrode at which electrons are gained is called cathode, this is also right. Okay, the electrode at which electrons are lost is called cathode, this is wrong. Electrons are lost, it should be anode. So the incorrect statement is this, correct? Okay, next question. Galvanic cell converts what? Okay, galvanic cell converts chemical energy into the electrical energy. Okay, yes, whatever electrons are there, it's getting converted and developing a cell potential of 1.1 volts. Easy. Okay, next question. Which of the following is statements is true for electrochemical Danial cell? Right, Danial cell. So Danial cell has two electrodes, zinc electrode and copper electrode. Electrons will flow from zinc to copper. Correct? This is what happens. Electrons. Current flows from copper to zinc. Right. Here, according to my understanding, here anode compartment. This is cathode. Now let us see, students. 19th question. Which of the following is true? They asked. So cations move towards copper electrode, which is a cathode. That's all. It's easy. So always zinc anode, copper. Easy. Sure. Next question. The lifespan of an Danial cell is increased by, oh, right. Careful question. Larger zinc electrode. Obviously, no, students. Why? Because zinc electrode has to transfer the electrons towards copper electrode. Correct? So this zinc electrode should be large, means larger means the lifespan. It should be that particular large that it can donate the electrons and towards the copper metal. That's all. It depends upon the anodic compartment. Careful. So the electrode, the particular electrode should be larger one. Next, the passage of current in Danial cell when copper and zinc electrodes are connected. Okay, so current always, what did we say? Copper to zinc, correct? I just now written is electrons from zinc to copper, current from copper to zinc. That's all. Next, the initial cell potential of the Danial cell 1.1 volts. You see? Okay. Next question. Consider the following. Consider the galvanic cell. Zinc sulfate, copper sulfate. The reaction at the cathode is. Oh, easy. Reaction at the cathode, they asked me. Simple as that, students. Check this one. Always at cathode, a reduction process happens. This is cathode. It's taking two electrons. Correct? This is reaction of the anode compartment. This is anode compartment. So they asked me the reaction at the cathode. So loss. This is oxidation. This is gain of electrons. This is loss of electrons. Loss of electrons. Easy? Easy. Very easy. So the option is B. All right. So how did you all feel, students? Today we have done the topic. Which topic today? We have discussed what is meant by or what actually is the concept of redox reactions. Yes, we have discussed a topic called what is meant by a galvanic cell. Correct? We have also seen what are the related MCQs to this. So I'll be coming back with more videos about electrochemistry. We'll be doing numericals in the next. So my request is please like, share the video. It is for free only, no, students. Yes, it's for free, right? We are going to reach you. I want your support. Yes, WOC is always with you all. Remember, I'll come back with the next video. WOC is always with you all. Always with you all. So, right. Please share, like, share the video. Thank you so much. Coming up in the next video, we'll be learning about numericals of your Nernst equation and we'll be doing EMF of the cell. Bye-bye, students. Take care.